Okay, we're in section 29, the homework. I'll go through the homework. And some of these questions you might find difficult. You also may want to help yourself by using technology. All right, so I'll start by going to the whiteboard. And surely when I do these problems on the whiteboard, it may look a little bit different than what's being done in the notes. But that's the whole point. When you're doing homework, it may look different than what you're doing in the notes. Anyway, let me take a look. And first question is calculate the area bounded by the circle r equals 3. Well, at least they're telling me it's a circle. And I'm going to put this over here. They say it's a circle. I'm going to draw that down. Radius 3. I'll put this over here. And again, that's my attempt at doing a circle. This is circle. The equation's r equals 3. It's centered at the origin. All right, what do they want to do? They have the rays now, and the first ray they have is pi over 4. I want to point out a ray of pi over 4 looks like this over here. That's a ray. Theta equals pi over 4. Again, this is a circle, r equals 3. They have another ray, and they say the ray is pi. What does ray pi look like? It looks like this over here. All right. So what do they want me to do? Let me read it to you. It says calculate the area bounded by the circle. Well, I see the circle and the rays. Well, okay, so I see this. I'm going to shade it in. And let me just shade that in for you. Whoops, I think I made a mistake already, didn't I? And let me just undo it. Okay, I got to reread it to make sure that's what they asked for. Right, I think they want that region over there. Let me take a look. It says calculate the area bounded by the circle r equals 3 and the rays pi over 4 and pi as an integral in polar coordinates. So before I do that, I want to claim that I probably could do this without doing any calculus. And the reason why I'm looking at it, the area of the entire circle is pi r squared, right? So it'll be pi. I'll write this down for you. The area of the entire circle is pi r squared. What's r? R is 9. I'm sorry, r is 3, so when I square it's 9. But it's not the entire circle, is it? It's what? It's 3/8 of the circle. So it's going to be 3/8 of that entire circle. So what do you get over here? 27 pi over 8. You could also do this by a formula that you derived in Math 120, and that was the area of a sector is 1/2 theta r squared. Again, this I did by grade school. Basically, I looked at it as about 3/8 of a circle, and the entire circle was actually worth 9 pi, the area of it. Now, the circle, the area you knew in grade school was pi r squared for the area of a circle. This is what you did in Math 120. Well, let's write it down. What do you get? 1/2. Well, what's the theta over here? Well, the theta is going to be this angle over here, and that's going to be what? That's going to be 3 pi over 4, right? And what's r squared? R squared would be 9. What does this give you? Well, 3 times 9 is 27. You get a pi, and 2 times 4 is 8. You still get 27 pi over 8. Well, I would be shocked if I got something different. But what did they say? They said do it by an integration, and I'll put this down for you. Right? I'll hopefully get the same number, right? So I'm starting at pi over 4, and I'm going to pi. It's going to be 1/2. Let's see, r squared, which is 9. I'll just write down as 3 squared d theta. Again, we're showing the little tiny arcs now. Let's put this down. What do you get over here? Let's see, that's going to be 9/2 theta pi over 4 to pi. Hope I didn't make any mistakes here. It's going to be 9/2 pi minus pi over 4. This is 9/2. That would be 3 pi over 4, which can be 27 pi over 8. All right, let's look at the key. Every answer I'm getting, whether I went to grade school, Math 120, did Math 120, and this is Calc 2. All right, they're all giving me 27 pi over 8. Let's take a look. Bingo, got it. All right, let's do number 2. All right, what does this one say? Calculate the area of a circle. as an integral in polar coordinates. Well, you know what? Before I do that, I want to go back to what I did in grade school. But before I do what I did in grade school, I want to go to what I did in math 120 with polar coordinates. So I'm going to take a look at this equation over here. It's r equals 10 sine theta. I'm going to multiply both sides by r. So r squared 10r sine theta. Someone says, why do you do that? So we can get it back to Cartesian. This would be x squared plus y squared is equal to 10y. You get x squared plus y squared minus 10y equals 0. Complete the square. I'll add 25 to both sides to accomplish that. And what do you get over here? X. Well, I'll write down formally x minus 0 squared plus y minus 5 squared is equal, well, 25 is 5 squared. So what do I know? I got an equation of a circle. And its center is going to be 0, 5. And it's got a radius of 5. And something like this over here. So radius of 5. But I realize my circle doesn't look great. So what's the area of that circle? Pi r squared. So it's going to be 25 pi. All right, that's the area of that circle. So what they told me to do, though, is they told me to do polar, write down as an integration in polar form. So I think I can do that. It's the limits of integration that causes trouble. So what's going to be? It's going to be, let's see, it's going to be 1/2. Let's see, r squared d theta, right? So r squared would be 100 and sine squared, right? D theta. It's a limit of integration that gets me going. And I've got to look at this over here, and I'm going to start talking through it. And I'm going to just march through it. I'm going to, I'll start at 0. All right. And at 0, what would you get? You get the 0.0. And then what I do? I would move forward, yada, yada, yada. And the next number I'd come to is probably pi over 2. All right. Now, where would you be at pi over 2? Well, if you did pi over 2, you'd be at 10. You'd be up here. So what I'm going to claim over here is, and I'll shade it in for you. That first thing is just give me this region over here. Go from 0 to pi over 2. Now, of course, I hope you realize you could just simply say, you know what? I got half the circle now. I might as well just double it. Let me put that down for you. I'll double it, and I'll go from 0 to pi over 2. All right. Now, someone said, could I do a different integral than that? Of course you could, but let's take a look what we got over here. And again, I'm expecting in the end 25 pi squared for the whole circle. They want to do the whole circle. I got my integration down. I'm going to try to simplify it. That would be 50, 100, isn't it? And again, I hope I didn't make any mistakes here. 0 to pi over 2. Sine squared is going to be a tough one, isn't it? So put down 0 pi over 2. And I want to remind you that the squares should really be written as linear problems. Question is, can you remember? I hope you can remember this, that the cosine of 2 theta is equal to 1 minus 2 sine squared theta. That's something you learn in math 120. And let's see, that means sine squared theta would equal 1 minus cosine 2 theta over 2. I think I did okay. So let's write that over here. That's going to be 1/2 minus cosine 2 theta over 2 d theta. I got to do the integration. I know it looks difficult, but I got to do it. And it's going to be 100. The antiderivative of 1/2 would be theta over 2. And this would be minus sine 2 theta over 4. Limit integration 0 to pi over 2. Let's go to town, see what we get. You get 100. The upper limit's pi over 2, so what do I get over here? Pi over 2 would give me pi over 4, right? And then you get the sine. Let's see, 2 times pi over 2 is pi. That would be 0, so that's pretty good. Minus 100. The lower limit, gee, that's nice too. That's 0. What do you get over there? 25 pi. All right. So we're consistent with our belief that it's an easy problem, that the answer should be 25 pi. I got to go to the next page, look at the answer though. And again, we're just doing homework, 25 pi. By the way, I noticed they're doing different limits on it. They went to the full circle around from 0 to pi. You may want to read this stuff over here if it helps you. All right. I do suggest that reading is helpful if you can understand what you've read. All right, let's do this one over here. And again, I'm looking at it and they want to get that shaded region. I'm thankful for the pictures, not to deal with that part. And what I want to do is I want to, kind of read through it. And, I don't know the formula for that area at this point, but find the area of the shaded region. And it says what f of s, f of theta is. So I'm going to put points over here for you. And this point over here, if I did it, the point in polar form, the r would be 0 here and the theta would be 0. And that certainly stands to reason when I look at the formula for it. Then the question is, what's this over here? Well, that looks like where you get to pi over 2, all right? So what would the r be there? Well, the r in this case over here would be pi squared over 4 plus 3 times pi over 2. And they're sweeping out an area now. And that's between 0 and pi over 2. I clearly see that. This is being swept out like this over here. And again, they gave me a picture. All right, so what I'm going to do, I got to do it. And that's going to be, let's write this down. So I'm going to go from 0 to pi over 2. And then what do I get? I get 1/2. Well, I got to do r squared. That's going to be theta squared plus 3 theta squared d theta. We'll look at the key later, but I got to do some work over here. It's going to be 1/2. It's going to be 0 to pi over 2. That's going to be theta to the 4th power plus, let's see, that would be 3 theta cubed, which is 6 theta cubed. Remember, we have an answer key, and we're going to look at that answer key. I squared it. Now I got to do the integration. That's 1/2. And that's going to be theta to the 5th power over 5 plus theta to the 4th power. Well, that'll be 6/4, which is 3/2. Plus, I'm sorry, you know what? I made a mistake over here and I just noticed it. I'm thinking that I want to integrate and I don't want to integrate yet. That was just a multiplication problem. What's that going to be? It's going to be 9 theta cubed over 3, which is 3 theta cubed. Limit integration is going to go from 0 to pi over 2. All right. Again, when I do something, it may be different than what you do, but the intent is that we have an answer key. We can look at it. I'm going to kind of factor out this theta cubed on it because it looks really difficult for me. So theta cubed, and you're going to get theta squared over 5 plus 3 theta over 2 plus 3. I hope I didn't make any mistakes there. 0 to pi over 2. I'm going to keep moving along, and I want to simplify more. Get a common denominator, 1/2 theta cubed, and a common denominator of 10, right? Again, I'm not beyond making mistakes. I know I said a lot to you. And we're trying to encourage you. If you make mistakes, correct them. So what do you get over there? 2 theta squared. And then you're going to get plus 15 theta plus 30, right? I'm sorry, that's a 2. All right, I got 3 in my brain. All right, let's do it. And we get what? 1/2. Well, pi over 2 cubed is going to be pi cubed over 8. I'm going to keep working through this. Yes, arithmetic is important. If you can't do it, walk away. That's going to be 2 times pi squared over 4 plus 15 pi over 2 plus 30. Okay. Let's see if we can do it. Pi cubed. Let's see, 2 times 8 is 16. 16 times 160. And then I got this over here. Pi squared over 2 plus 15 pi over 2 plus, did I do that right? 2 pi squared over 2, 15 pi over 2 plus 60, right? Over 2. Oh, geez. 320 now. Pi cubed, pi squared, plus 15 pi, plus 60. You know what? Might as well multiply it out now. This is going to be pi 5, plus 15 pi 4, plus 60 pi cubed over 320. All right. Mistakes happen in arithmetic. Let's take a look over here. And let's see if I got that. 320. Did I get that? Yeah, I got that in the bottom. Pi 5, 15 pi 4. Yep. Did I get 65 cubed? Bingo, we got that. This is good news. All right, this one, I mean, I'll be honest with you, it's really easy to make a mistake. And we're not telling you to make a mistake. I'm just saying it's really easy to make a mistake. And what I'd like to do is I have a picture and I want to see if I can understand what they want me to do. They want me to give the area of that shaded region. So what I'm going to do over here is I've got to talk about how to complete that out. So over here, I'm going to say theta is 0. And I got a picture, right? So if theta is equal to 0, what would r be equal to? R would be equal to 3. All right. So what I'm going to claim over here is that something's being swept out here, and I'm going to put that in over there. And again, I know I'm not doing a great job, but over here, I do know that r over here is equal to 0. When would that occur though? At theta equals, and again, we're looking at this over here, when theta equals 3. All right. So I'm going to say this sweep out of that area problem occurs between theta 0. Let me write this down for you. And 3. All right. Now what do I do? 1/2 r squared is going to be 3 minus theta. We have a key to look at. Don't worry about that. D theta. All right. And let's get the area. All right. Let's put this down. So what do you get over here? 1/2, 0 to 3. This would be 9 minus 2 theta plus theta squared d theta. 1/2, 9 theta minus theta squared plus theta cubed over 3. Limit integration would be from 0 to 3. 1/2. 3 times 9 is 27. 3 squared is 9. And 3 cubed over 3 is also 9. What's nice about the 0? Every term evaluates to 0, and 1/2 times a 0 is a 0. Let's keep going through this. And what do you get over here? You would get 27 halves. Again, I'm going to say this again. Do mistakes happen? Of course they do. Let's look at the K and see what they get. And I made a mistake somewhere. So someone says, where'd you make the mistake? I just don't know. And I'll take a look at this. And I think I might have copied wrong. And now I see the mistake right away. So someone's going to say, oh, you see a mistake, forget it. Don't worry about it. No, mistakes matter and they have consequences. And someone says, how do you see mistakes so quickly? One, I know I got a bad answer. So I kind of quickly look back over this and I said there was a problem over here. And the problem is this term here. And I'll correct it now. And that's what's nice about having an eraser. I can correct these things. What's that going to be? Well, 9 is minus 6 theta. Let me try again. 1/2. What do you get over there? 9 theta minus theta squared over 2. And 2 goes to 6 3 times plus theta cubed over 3. Lynch integration 0 to 3. All right. So let's take a look at this. 1/2. That's going to be 27 minus 27 plus 9. And again, the lower limit 0. Every term on the inside there evaluates as 0, so it's times 0. So what do you have here? 1/2 times 9, which is 9 over 2. Let me say it again. Mistakes happen. Let's look at our K, and I'm seeing it. All right. Now, I want to go to the next page. There's a question related to this problem over here. I'm going to go to the next page. I want to claim to you that they have a question over here. Now, granted, you may look at this stuff and say, I'm not interested. Move on, right? Like a lot of things you're not interested. Don't think you have to be interested in. Like someone says, oh, opera is really good. You got to start listening to opera. Move on. If you don't like it, don't listen to it. All right. But I got to thinking when I did this problem about a good question. And, what I want to do is, between what two angles is the leaf formed? So I want to go back to the other page and I want to try to comprehend what they said to me. All right. So I'm going to go over here and give me 1 second to do so. I got to get my eraser out. Now someone says, I don't know what the hell a leaf is. I'm going to point it out to you. The leaf is this portion here. So I'm tracing it through. That's all I'm doing. Now, here's my problem. Again, I'm not saying it's a trivial problem. I'm just saying it's my problem. I have to think. What's the worst part of thinking? It takes time. So what I want to do is I want to draw the first angle in. And that's where they intersect. That's where it starts. And then it goes like this. All right, I'm going to call this angle theta over here. All right. Now, the next thing I have to realize is that the other angle is actually over here. I put this in blue. And that angle is like this. Now, why am I saying that? I'm saying that this other angle over here, it's basically, it's going to return the opposite. All right. What do I mean by that? The R is going to be a negative. It's going to push it back up there. Excuse me 1 second. I think I made a mistake there. All right. Here comes the trouble. So what's the first angle? Well, I'm looking at it and I'm thinking the first angle is just theta, right? The first angle is theta. But the next angle, right? And what's that going to be? Well, looking at it, I'm starting to realize the next angle, the blue one, is just theta plus pi over 2. All right. I'm sorry, not pi over 2. I'm sorry. I made a mistake there. I guess my thinking's not working so well. Let me get my eraser out. Okay. So remember what I said about this over here. This has a negative R. All right. All I know is the points are going to be the same. All right. The points are going to be the same. Here comes my trouble. Let me write it down for you. And what's the point going to be? It's going to be that R value. So let's write this down. So 3 minus theta. Well, remember, this guy over here is going to be minus R. So that's going to be theta, right? Which now is this. So theta plus pi minus 3. All right, let's see if we can do that. So what do you get over here? Well, it's going to be a tough one, isn't it? 2 theta. Right, I'm trying to figure out theta now. You can, of course, check this, by the way. Then you would get 6 minus pi. So now I know what theta is. So what's theta going to be? Theta is going to be 6 minus pi over 2. So I hope you realize we're talking about this theta over here. So if you thought about it now, the leaf is formed between, this is the theta now, 6 minus pi over 2. And then I got to get the next one, which is the blue angle. What do? Well, I got to add pi to that, don't I? So let's write that down. So 6 minus theta over 2 plus pi. Well, that's like 2 pi over 2, right? That's going to bring us to 6 plus pi over 2. That's the theta range of theta that's going to bring me to make that leaf. Let's take a look at the key. That's 102. And what do I see? I see that answer over there. Let me just point out the 6 minus pi over 2, 6 plus pi over 2. All right. That takes thinking. I want to also point out you may want to play around with your computer algebra systems to draw the leaf between those two. And that's pretty easy to do. All right, let's do this one over here. And this is, find the total area enclosed in this object over here. And again, what I'm looking at, I know how to do it. It's the limits that cause me trouble. So let's write this down. So it's going to be, it's going to be 1/2. Let's see what the R squared, right? And that's going to be 3 minus 3 cosine theta squared d theta. It's the limits that cause me trouble. So let's just talk about it one step at a time. And I'm going to start at 0. I'm going to start the theta at 0. Now, if you start the theta at 0, what would you get? Well, you get 3 minus 3, which is R would be 0. So I'm starting here. And then I'd probably go to theta equals pi over 2. Now, if I did theta equals pi over 2, what am I getting? It gives me, let me write that down for you. That would just give me 3. So it's over here now. So I got this over here. This is being swept out now like this. Whoops, sorry about that. So that gives me the first sweep. All right. Then what would I probably go to? I'd probably go to theta equals, what I got? Probably pi, right? And what would that give me if I did that? Well, what would R be? It would be 3 plus 3, which is 6. So it brings me way over here. okay? So I'm going to say I got half of it. So I'm just going to simply say between 0 and pi, I've got half the object and it's symmetric. I'm just going to double it. And of course, what I'm going to do now, I'm going to do the integration. Now, of course, if I make a mistake, I'll know this because we give you the k. All right. You're going to get this 0 to pi, 9 minus 12 cosine theta plus 9 cosine squared d theta. All right. Now, granted, the integrations can be nasty. I'm not going to say it's a nasty integration. You may not remember. If you can't remember something, walk away, especially on exam. Don't stare at something if you don't know what to do. I mean, it's not going to help you. All right. I'm going to write this down now. The cosine squared theta is equal to cosine theta. I'm sorry. I made a mistake already. I'm thinking something else. Sorry about that. Cosine 2 theta is equal to cosine squared theta minus 1. So cosine 2 theta plus 1 over 2 is going to be the same thing as cosine squared theta. So I'm gonna pop that in now. All right. And yeah, it's work. I realize that. It's going to be 0 to pi, 9 minus 12 cosine theta plus 9 times, well, it's going to be cosine 2 theta plus 1 over 2 d theta. And I have to clean it up. And I realize that might be difficult to do, but I want to clean it up because it just doesn't look right to me. So let's write this over here, 0 to pi, 9 minus 12 cosine theta plus 9 halves cosine 2 theta plus 9 halves. All right, let's keep going. 0 to pi, do my integrand. 9 halves plus 9. Well, it's going to be 18 plus 9, 27 halves minus 12 cosine theta plus 9 halves cosine 2 theta d theta. Let's do integrations and then we'll pop the numbers in. So you can get 27 halves theta minus 12 sine theta plus 9 quarters sine 2 theta. Limit integration would be 0 to pi. Let's see if we can do it. You're going to get 27 pi over 2. Well, let's see. The cosine of pi is 0, right? I'm sorry, the sine of pi is 0, and the sine of 2 pi is 0. That's nice. Minus the lower limit 0, so you get 0, 0, 0. Get a nice number. I'm not saying it's right, by the way. I'm saying get a nice number. What do you mean a nice number? A number that I can actually write down. Let's take a look at their answer. Their work may look different. I did okay. All right, I did okay. All right, let's do number 6. And I'm going to go to the next page because they do give me a picture, and I want to know the picture they're dealing with. And it's r equals 4 minus 4 cosine theta. I'll write that down. So r equals 4 minus 4 cosine theta. And I want to get the area that they have shaded there. And I think I can do it. And someone says, how can you do that? I need to look at the picture. And I'm getting a little better, not great at it. I've never been really good at this. So I'm going to say the r in the beginning looks like, I'm going to say theta 0 and the r is 0. Let's see if that's true. The picture's going to be deceptive. Well, if theta is equal to 0, you get 4 minus 4. Yeah, that looks pretty good. Now what's up over here? I'm going to say this probably is pi over 2. And what would you get at pi over 2? Well, the cosine of pi over 2 is 0, so you get 4. That looks good. The r is 4. I'm seeing it. So what I'm seeing now, I'm seeing my integration. My integration occurs between 0 and pi over 2. 1/2 r squared d theta. All right, I gotta do some work over here, and it's always tedious for me to do it, but I want to do the work. The more work I do, the stronger I get. And you really want to exercise before you get to exams. So I'm gonna say I'd factor a 4 out, so that's 16. 16 divided by 2 is 8. Make sure I did that right. 4 comes out, 4 squared is 16. Yeah, that looks good. And then I get what? I get 1 minus 2 cosine theta plus cosine squared d theta. And I kind of remember, maybe I don't remember, but let me write this down. 0 to pi over 2. 1 minus 2 cosine theta. And then remember we did this before, right? And that was cosine 2 theta plus 1 over 2 d theta. Well, I'm going to borrow a 2 from the 8. And what do you get? You get 4. 2 minus 4 cosine theta plus cosine 2 theta plus 1 d theta. And again, I'm still working. 4, 0 to pi over 2. And you're going to get 2 plus 1, which is 3, minus 4 cosine theta plus cosine 2 theta d theta. This equals 4. 3 theta minus 4 sine theta. Yep. And then it's going to be what? Plus, let's see, that's going to be sine 2 theta over 2. You know what? I want to go backwards. I want to see if I did say something wrong over here. No, I didn't say anything wrong. I thought I did. Sometimes I think back and I said, did I do that or did I do it right? And let's just take a look at this. I have to do this now. I got to evaluate this thing. And it's going to be 4. That's going to be 3 pi over 2. The sine of pi over 2 is 1. And the sine of pi is 0. I'm not going to write that down. Minus, well, 0 is nice because you get 4 times 0. That's pretty simple. And what do you get over here? Well, I'll write this down for you. And again, I hope I didn't make a mistake because it was a long problem, wasn't it? It's going to be 2, 3 pi minus 8. And did I do that right? 3 pi minus 8? Yeah. Then what are you going to get? 2, 3 pi minus 8, which is going to be, did I do that right? Yeah, I think so. 6 pi minus 16. Boy, I hope I didn't make a mistake. Oh, look at that. Miracle. I kid you not, miracle. That was like a problem I didn't enjoy doing, actually. All right, let's take a look at this one over here. We got an equation over here. I got a picture. Let me go to the picture for you. And the picture, I got to remind myself, it's r squared, 36 cosine 2 theta. Let me go back and read the question. Find the area enclosed by one loop. I think I can handle it. Okay, so one loop. Now what I'm going to do is I think I want to start here. And again, they give you pictures for a reason, by the way. So I'm going to say, you know, if theta were 0, right? If theta were 0, what would you get? You'd get cosine 2 times theta, which would be cosine of 0, which is 1. You get r is 6, definitely. All right. So I'm going to say, and then I'm going to go this way over here and move my thetas. So what would the next theta you want? I want to get over here. And someone says, I wonder where that would occur. It's when the cosine of 2 theta becomes 0 now, because I want the r to be 0. And when would that occur? When theta is pi over 4. And you'd get r to be 0 then. So I'm going to get this over here. Now someone's going to say, is that what you wanted? I do. That's what I want. And so I'm going to shade in what I got over here. And again, my understanding of it this over here is this is just a half of a leaf. So I want to get a full leaf, so I have to multiply it by 2. I'll put this over here now. So it's 2. And I'm going to go from 0 to pi over 4. 1/2 r squared time, I'm sorry, d theta. All right, I have to do the work. I'm going to get 36 cosine 2 theta d theta 0 to pi over 4. Again, I'm not beyond making a mistake. I know I tell you that a lot, but it's so true. It's going to be sine of 2 theta over 2, limit distribution 0 to pi over 4. And that's going to be 18. And let's see, you get sine of pi over 2, which is 1, right? Minus the sine of 0, which is 0, which is going to be 18. Let's see what they got. Oops, it's on the other page, I guess. Yeah, 18. All right, feel good about that. Okay, let's keep going. And I got to do this one now. And again, I'm thankful for the picture because it helped me somewhat. But again, I might be totally confused. And if so, all I can say is, think, and maybe work at it. And let's start the beginning. All right. So the beginning is going to be, R. Well, I'm over here. And what would that be? Let's see. I'm going to start theta at 0 again. And what would you get over there? You would get R to be 5. Now someone says, why don't you think it's that one over there? Well, that one over there would be obtained at another number. And the reason it look like that would be 15. Why would I say that? Because the cosine of theta would be, sorry, maybe I shouldn't have said 15. What's supposed to be? Minus 15 would still be 15. I'm sorry. It's still 15. All right. Because minus 15 would be, a directed distance that would occur. That occurs when you're at, what number would that be at? So that would be at pi. All right. So you get 15 over here. So this one over here, this would occur when you get pi. Now this would be this point over here, which is 15. So anyway, I got this one over here. Then the question comes is, when does it hit this one? Well, when r equals 0. So I want to know, when does r become 0 when I move forward from theta equals 0? Well, I don't know. I'll write this down now. And what does that equal? 10 cosine theta minus 5. Well, I got to do that. What does that mean? Cosine theta would equal 1/2. And when does that occur? That occurs at 60 degrees, or pi over 3. Okay. So what did I just accomplish there? Just this part of it, which is again half of it. So I'm going to write this down for you. So it's 2. I'm just doing half of it, and I'm doubling it. 0 to pi over 3. 1/2 10 cosine theta minus 5 squared d theta. Well, again, I got to do the integration, then I'll look at the work. And when I do the work, I'll do the work. All right. So what do you get over there? I'm going to maybe do arithmetic for you. Let me sum pi over 3. This could be frustrating for you, but 2 times half is 1. I'm going to factor out a 5, which would be 25. Then you'd be left off with, let's see, a factor out of 5, right? That would be 2 cosine theta minus 1 squared d theta. And you're going to get 25, 0 to pi over 3. Let's see, that would be 4 cosine squared theta minus, let's see, 4 cosine theta plus 1 d theta. I know it's annoying, by the way, but I have to do it. You get 25, 0 pi over 3, 4. Cosine squared is going to be cosine 2 theta plus 1 over 2 minus 4 cosine theta plus 1 d theta. Let's keep going. 25, 0 to pi over 3. 2 goes into 4 2 times, so you get 2 cosine 2 theta plus 2 minus 4 cosine theta plus 1 d theta. You get 25, 0 to pi over 3. 2 cosine 2 theta minus 4 cosine theta plus 3 d theta. We're ready to do the integration now. 25. That's going to be sine 2 theta. Yep. Minus 4 sine theta plus 3 theta. Integration 0 to pi over 3. Okay, I know it's tedious and I don't enjoy doing it myself. Get a little tired after a top while doing that. 25. Let's see. That's 60. That's 120. Root 3 over 2. Minus 4 root 3 over 2. Plus pi minus 0. Well, all zeros. I'm not going to put that down, but it's 25 times 0. Let's see if we can do it. And I'm going to common denominator 2. 25. This should be root 3 minus 4 root 3 plus 2 pi. And this is going to be 25, 2 pi minus 3 root 3s. And let's look at the answer key. And I'm going to have to take it from this. Gonna copy it. Paste it in over here. I know this is difficult, but we need to look. 50 pi minus 75 root 3. Bingo, we got it. We did it right. Again, what I'm looking at, I know this answer might look different to you. It's the same answer. Boy, it's so small I can't grab it. Sorry about that. I'm really sorry. I'm going to blow it up here. Sorry about that. I had a hard time grabbing it. It was so small. That's 50 pi minus 75 root 3. Looks good. All right. So number 9. Oh, let's do it. And it doesn't look easy to me, I'll be honest with you. I gotta make sure I understand the question though. It says it's a circle, at least it gives me that. Let's write this down. R equals 12 sine theta plus 12 cosine theta. I'm going to multiply both sides by r, and what would you get? R squared equals 12 r sine theta. I'm just going back to my mth122 days to do that. 12 r cosine theta. Well, this is x squared plus y squared. And this is going to be 12y, and that's going to be 12x. So you get x squared minus 12x plus y squared minus 12y equals 0. Complete the square, plus 36. Complete the square, plus 36. What do you get over here? X minus 6 squared plus y minus 6 squared equals 72. So what do I know? This is a circle. Well, he did say it's a circle, didn't they? The center is, let's write this down, 6, 6. And the radius is the root of 72, which is going to be 6 root 2s. All right. Now, granted, I'm not really interested in drawing a good picture, but I guess I should draw a picture, right? So, 6, 6, center, circle, maybe something like this over here. I'm just drawing a crappy looking circle in there. All right. And so, why do you draw the crappy circle? I'm not interested in drawing a good circle. I'm not interested. But what they say, maybe I should draw a better circle than that. That's so bad that I can't even see it's a circle. So I got something like this over here. And the center's at 6, 6. So what was your question? Let's go back and read it. Find the area, the part of the circle that's in the fourth quadrant. So they're talking about this part. All right. So again, for me, to be honest with you, it's never easy. It's just never easy. All right. I have to think, and thinking is never easy for me. So I'm going to write this down. And I'm going to write the integration down. And it's going to be 1/2 r. When I say it's not easy, the limits are not easy for me. That's going to be the r squared, which is going to be 12 sine theta plus 12 cosine theta squared d theta. And this is the part, I mean, it really kills me to do it. So I gotta get it. So what do I know of over here? I know the r is 0 there. All right. Let me see if I can convince myself of that. Well, certainly the x and y are 0 there, right? It's at the origin, isn't it? And that certainly stands to reason, because if I put the x and y to be 0, I would get 36 plus 72. So yeah, it does. The origin's good. I know it's there. And that means the r is 0. When does the r become 0? Well, let me write this over here. If the r becomes 0, when this happens, and again, this is the part where I have to think. What does that mean? Well, let's write this down. 12 sine theta would equal minus 12 cosine theta. Well, I'm going to divide both sides by, and so I guess by oh, this looks pretty simple. It's the tangent of theta. I'm dividing both sides by cosine theta. And I'll divide both sides by 12 is minus 1. And this occurs at minus pi over 4. But it's a tangent function, keeps repeating itself on its length of a cyclic length, which is going to be pi, right? So pi k. So the question is, I'm looking for an angle between 0 and 360 degrees, or 0 and 2 pi. And I'm going to say that the first one I'd hit would be 3 pi over 4. So I'm going to claim when theta is 3 pi over 4, this would give me r equals 0. If you want, you can verify that. All right. So I'm going to start there, go over here, 3 pi over 4. Then the big question becomes, what do I get over here? How do I get there? How do I get there? And that might take some thinking. And so if I'm at 3 pi over 4, or it looks like I'm sweeping over, and I'm gonna say I need to move forward. All right, so let's do that. So theta, where I'm at 0, I'm going to go to the next quarter pi, which would be pi. And what would you get over there if you did that? And again, if you have no accurate picture, that's fine. My pictures are not great. So that would give you what? If I did pi, the sine of pi is 0, and you get minus 12. Well, let me just see if this makes any sense to me. All right, so I'm going to rotate. I'm rotating my angle. 3 pi over 4. I'm over here, and I would get the 0. And then when I get the pi, right, that's over here, it would be a negative number, which means it's way over here. So that certainly makes sense to me now. So I'm going to say it stops at pi. Now, granted, if you're using technology, graph it. You can graph it out using technology, and you can graph between those things over there. I think I've shown that to you in Grapher and in Sage. If not, you can always come by and I can show you that. And certainly if you come by with a question, I may have to refresh it with it. It would be nice if you're prepared with your questions. I got to do some arithmetic now, and it's going to be crazy for me to do it. So 1/2, I'm going to factor out 12 squared, which is 144. 3 pi over 4 to pi. This would be sine squared theta plus cosine squared theta. And then I get sine cosine too, right? D theta, I got to integrate that. That's going to be a problem, right? So we get 72, 3 pi over 4 to pi. Sine squared with cosine squared is 1. And what's 2 sine theta cosine theta? It's sine 2 theta. Let's keep moving. This is 72. Integration is going to be easy now. This is theta minus cosine 2 theta over 2. 3 pi over 4 pi. 72 pi minus cosine of 2 pi over 2. The cosine of 2 pi is 1. That'll be 1/2 minus 72. That's 3 pi over 4. Minus, let's take a look at this. I'm be careful about it. 3 pi over 4. This is 3 pi. Times 2 would be 3 pi over 2. Well, that's just 0. That's easy. And let's see if we can do that. So what do you get over here? 72 pi minus 36 minus, let's see if I can do that. Well, I'm just going to say this because I want to do arithmetic later. 3 times 72 pi over 4. Let me write this as 4 times this over 4. It makes it easier for me to do the arithmetic. Maybe not for you, but it makes it easier for me. And that would be 4 of those minus 3 of those, which is 1 of those over 4. I'll do that later, minus 36. That would be 36 over 2, 18 pi minus 36. Again, I am not beyond making mistakes. And bingo, we got it. All right, we got it. Again, there's work there. I want to point out the difference between my chicken scratch and typed up. You're going towards that. I'm not saying you're there yet, but you're going to be able to type things up at some point in your careers. You got to. You can't be feeding chicken scratch to people. All right, why do I do chicken scratch? Before I write my notes, by the way, there's a tremendous amount of paper used before I write my notes. And then when I go to my paper, I feel comfortable. I understand the problem. I formulate it, typing it up. All right. So I think we're done. I'm not sure, but yeah, we're at the end of it. And I know this is tough. I know it's a lot of work for students. We're trying to encourage you to do that work. Thank you for paying attention. And again, if you need additional support, please come by during office hours and I'll try to help you. Sometimes it's really hard, but I'll try to help.